In 8.2, we're going to talk about sequences in series. So a specific type of sequence is called an arithmetic sequence. An arithmetic sequence is when you add to get from one number to the next. So if I had a sequence like 1, 3, 5, 7, 9, we're adding 2 to get from one number to the next. So what we're adding, that constant number that we're adding, is called our common difference. So 2 would be the common difference. So in this section, we're going to be finding the common difference and coming up with our own equations to come up with a sequence. So in example 1, we have to tell whether each sequence is arithmetic. So we want to see if we're adding the same number to get from one number to the next for each of our terms in the sequence. So if you can see, I'm adding 7 to get from -9 to -2, from -2 to 5. Again, I'm adding 7. From 5 to 12, adding 7. And from 12 to 19, we're adding 7. So because it's a constant number, because we're adding the same thing to get from one term to the next, we would say, yes, this is arithmetic. Now let's look at B. So we are adding -8. So technically we are subtracting 8 to get from one number to the next here. For the next term, we are subtracting 6. Then we're subtracting 4. And then we're subtracting 2. Because these are different numbers and we don't have a constant number that we are adding or subtracting to get from one number to the next, that would mean that no, this is not arithmetic. So it has to be the same number that you're adding to get from one term to the next one. So on the next page, let's take a look at number 1. Again, we're going to tell if the sequence is arithmetic or not. So here, I'm adding 3 to get from one term to the next. For each one of our terms. So because it's the same number, because we have a common difference, we would say, yes, this is arithmetic. For number 2, here I'm subtracting 6. I am subtracting 6 again, subtracting 6, and subtracting 6. So because this is the same number that I'm either adding or subtracting, I'm subtracting here, but because all of these are the same number, we would say, yes, this is arithmetic. And then for number 3, I'm subtracting 4. Here I'm subtracting 2 right off the bat. Because these two numbers are not the same, we don't have a common difference here, so we could say no, this is not arithmetic. So next we're going to be writing rules for an arithmetic sequence. Rules are going to be the formula. So like that's specific sequences formula, the equation that we could plug in a number and it would give us a certain term of the sequence. So the nth term of an arithmetic sequence with the first term a sub 1 and common difference d is given by this. So a sub n tells us what the nth term is, so that number of term. A sub 1 is going to be the first term in our sequence. N is the number of term. And then D is the common difference. So it's what we're adding or what we're subtracting to get from one number to the next. Right, so in example 2, we're writing a rule for the nth term. So our formula is a sub n is equal to a sub 1 plus n minus 1 times d. So I need to figure out what my first term is. I need to figure out the common difference, and that'll give us the formula, and then we can find whatever term, which would be n. So we're going to write the rule first. The first part of this question is to write a rule for the nth term. So n is just going to be a variable in our formula. So first thing we want to do is find out what our a sub 1 and what our common difference is. So a sub 1 is the first term. That would just be 3. Now our common difference is what we're adding to get from one number to the next. So from 3 to 8, I'm adding 5. From 8 to 13, I'm adding 5. And from 13 to 18, I'm adding 5. One way that you can find your common difference is you can take the second term and subtract the first term from it. So our second term here is 8. So 8 minus 3 would give us 5. So that's our common difference. So this is one way on how to find D. So our common difference is 5. So we're going to plug both of those into our formula. So I have a sub n is equal to 3 plus n minus 1 times 5. So this is our rule. This is our general equation here. The second part of this question says find a sub 15. So we're looking for a sub 15. Notice how a sub n has an n in the formula. A sub 15, we're going to plug 15 into n. So I have 3 plus 15 minus 1 times 5. So a sub 15 is equal to 3 plus, make sure you follow your order of operations. We have to do the parentheses first. So 15 minus 1 would be 14. So we have 14 times 5, which would be 70. So 3 plus 70 would be 73. So our 15th term would be 73. If we wanted to, we could just keep adding 5 to get from one number to the next, to the next, to the next, to the next, until we get to our 15th term. But if this asks for something like our 100th term, you wouldn't have time on a test or quiz to keep adding 100 5s to your sequence. So that's when the formula comes in handy. So the first part of this question says to write a rule, which is the formula, so you need that n as a variable in it. And then the second part is to find the 15th term, which is when you plug in 15. Now it can ask you for any number in our sequence. This one just so happened to ask for the 15th, so that's why we plugged 15 into n. So we're going to do the same thing for b. So first thing we want to do is find a sub 1 and our common difference. So a sub 1 is the first term, that is 55. And then our common difference is what we're adding or subtracting to get from one number to the next. If you're subtracting, your common difference is just going to be negative. So one way that you can find your common difference is take the second term, so 47, minus the first term. So 47 minus 55 is negative 8. So I'm subtracting 8 to get from one number to the next for all of my numbers in my sequence. So my common difference is going to be negative 8. So even though we're subtracting, got to make sure that it has that negative there. So common difference has to be negative because we are subtracting. So my formula is a sub n is equal to a sub 1, which is 55, plus n minus 1 times d, which is negative 8. So this is our rule. Your rule has n as a variable in it. The second part of this question says we have to find a sub 15. So we're going to plug 15 into n. So I have a sub 15 is equal to 55 plus 15 minus 1 times negative 8. So we're plugging in 15 into the n. So just like we did before, we're going to follow our order of operations. We have 14 times negative 8 would be negative 112. So 55 minus 112 would give us negative 57. So our 15th term is negative 57. This question asks for the 15th term and the general equation, the rule. The rule means that we keep n as a variable. All right, last example for today. We're going to do the same thing, but this one, it just so happens to ask for the 15th term again. I'm going to change it to ask for a sub, let's see, let's make it a sub 100. It's the 100th term of our sequence. It's probably going to be a really big number, but that's fine. So our formula is a sub n is equal to a sub 1 plus n minus 1 times d. So we need to figure out what our first term is, or a sub 1, and what our common difference is, d. So our first term is going to be 7. It's the first term that's listed in our sequence. And our common difference is what we're adding to get from one number to the next. So here, I'm adding 4. I'm adding 4 to get from 7 to 11, adding 4 to get from 11 to 15, adding 4 to get from 15 to 19. So my common difference would be positive 4. So let's plug that into our equation. So I have a sub n is equal to 7 plus n minus 1 times 4. So this is our rule. This is our equation that we're going to use to find whatever term we want. So we were asked to find the a sub 100th term. So a sub 100, we're going to plug in 100 into n. So I have 7 plus 100 minus 1 times 4. So this is a sub 100 is equal to 7 plus 99 times 4, which would be 396. And then 7 plus 396 would be 403. So my 100th term of the sequence is 403. Now you can sit here and just keep adding 4 to get from one term to the next, until you get to the 100th term. It's going to take you a long time, and you won't have time for that on a test or quiz. So that's why we come up with the formula. We have to have our rule first. So this is the first part of the question. Make sure your n is the only variable that's in it. So you have to plug in your a sub 1 and your d into the equation. But you leave n as a variable, and then whatever term it asks for, that becomes your n. So it asks for the 100th term, which is what we plugged into n. So this is the first half of the notes. We'll call it part 1. Make sure you turn in part 1 by the end of class on Thursday. So part 1 needs to be turned in. We'll do part 2 on Friday, but make sure you turn in part 1 notes by the end of class on Thursday. And then after you turn in the notes, you can start working on the first half of the homework.